Oh, hello. So today I will add on the board on micro switch. This micro switch. So it's a it's a simple switch. To the Arietta board, and this button will be controlled by Python, and it will allow the system to automatically shut down once the button is pressed. And all my videos will be streamed here, all my future videos, and I will do all my stuff live directly. So right now I have to solder the pieces of, of I'm following this this circuit. Arietta G25, G25, gpio, to read on board button. No, I don't want to read on board button, but it's interesting. There is an on board button. Of course, there is an on board button. Okay. So what I want to do is this one. So you have an Arietta G25. I think these pinouts are wrong, but I'm not sure right now. Anyway, the pins are here. um, So you have to install also this one, I think. Git clone, Python setup, install, blah blah blah. Okay. And the pin, let's see, Arietta. Out. So on their website, here I want to use this part of this circuit, but they say to connect the input line, and here there are some advice on the pinout to use, and they said to use the third, the 28, and the GND 9. But if I go here, I see that the 3.3 volt is on pin 5, and the GND is 9 is correct instead. And on pin 28, there is this TXT1 that I think it's interesting to let it free, so I don't get it. I think I will use another one, maybe this pin. Okay, let's try and see what it happens. So right now I will try to show you that I'm soldering. As you can see, there is a 1K, yeah, there is a 1K resistor. One is done. The other pin in the resistor. Then I will use this and then I have some wires. This wire I think I have to buy a new webcam for this kind of stuff. Okay, so now it's connected, this one, and also the button. So there is another one wire to connect. So the schema, let's see the schema again. Okay, so there is a one side of the button, it's connected to ground. This will be ground, will be grounded. This is enough. You'll be grounded, mister. Okay. So one side will be grounded and the other side, one side will go to 3.3 volts, and in the same point you will be connected to one of the input line. So what we'll have to do next is to connect this piece of electronics to the board, to the pin on the board, and then okay, it's only one. So this line, the line with resistor, according to schema, this will be connected to 3.3 volts, and on the same side of the 3.3 volt, this side, I will connect a wire to the input pin, and this other side of the button will be connected to ground. So I need another wire. So the next time maybe I will try to control a LED, but we will see if I need it. Right now it's not important. The button instead it's more important because I want to be able to control the board in some way without need to connect to it physically. So the best things to do here right now is to grab, take, install a button, control a button, and at least have the possibility to shut down safely the board. In my idea, the project, the file system of the board should be run on RAM, or at least the file system should be read-only. And I see there is an interesting project called Yocto Linux or Yocto project or something like this that allows you to, okay, we have done with this, that allows you to prepare an image for the board, for a board, and there is support also for Arietta. There is a lot of support for Raspberry Pi, but Arietta is also supported, and you can remove all the stuff you don't need in the kernel, in the image, and make an image that run very fast, go up, start up very fast, and it works very good. And and it's interesting for my project because I want something that it's able to start very fast and to control it, to do some very few things. Okay, so now what I have to do is to solder also other pins on the board. Here there is a USB cable connected on this pin. I have to go to, let's see which pin I need. According to this one, okay, according to this one, maybe the 9 pin is already connected, so I have to grab another, to put another wire here, paying attention to not remove this one. And I don't like the idea that there is only one GND line. Maybe there is another one here. Yes, there is one. So there I think I will grab GND from this port, the last GND, and 3.3 volts. So this port is anti-abuse with the debug port interface. So, blah blah blah. Okay, so, and there is also this port available, the 5th pin, and there is also this 3.3 volt. So I think I will grab, as we said, So as you can see here, right now this side is 3.3 volt, and this will go to the input pin, and this will go to the GND. So I will connect this one. I think I will use this. I will not add a Wi-Fi module here, so I think I can directly connect this pin, pin number 5. So 1, 2, 3, 4, 5. This pin for the GND line. Sorry. Solder it. This will be the GND line. Okay, it's inside it. Where is the okay solder? I will from right. Okay, definitely better. Okay, it's not easy to solder on this kind of board, so if you're not good with soldering, ask to a friend, ask to a technician, ask to someone who works with electronics. It's the same people that sold this kind of stuff, the resistors, buttons, something like this can help you on this problem. Okay, I did it right. Okay, I added the GND line. Then there is the .3 volts. Let's see, 0.3 volt. With the resistors, and is the pin number 3.3 volt, 5th pin. So 1, 2, 3. Sorry. 5th pin is this one. Okay, so let's connect it. not so easy. It was better if I added a pin out, a pin, female pin to this board, but I don't want to do this right now, so I will leave it like this. But maybe it's better if you use a female header and to install the female header on it, so it will be easier to plug some device on it. Not device, some components on it, like resistors and so on. So what's so stupid? Wise. Come on. It's connected, yes, but I don't like too much how I solder it. Let's try again last time. Okay, leave it like this. Okay, now the last pin. I think I will connect the one, the 29, the 29 pin PA. I don't know what's this pin are. So 9 is the GND line, so I will connect this one, the next one to the GND line. That is good enough. Right now I'm using the webcam of my MacBook. It's not easy to show you what I'm doing. That's why I will buy I think I will buy a webcam. Okay, this is definitely better than the previous one. And okay, I check again. So pin 5 to GND line, okay. This to the pin 11. That's the next one to the GND, so PA24. And this one to the 3.3 volt. And it's enough for now. So let's try to, okay, now let's try to plug it. Plug the board. Let's see if it works or not. Okay. For this tutorial, I think I can connect directly the board to. The last time I added the USB port in order to use this device. It's a USB to Ethernet device, and I use it this stuff because it works. The connection is more reliable if you use directly the board with if you connect it with a micro USB cable, the board to your computer, it will show you as Ethernet gadget device. So there is an emulation through USB of an Ethernet port, and in this way, yes, it works as a Ethernet device, but it's slower than a real Ethernet device. And that's why I decided to add an Ethernet device. It's not, of course, it's again a USB device. So the bandwidth is the same because the limit is not the Ethernet but the USB. But as I can say, it's better. It works better than the emulated Ethernet gadget device. So once connected, the device will show you as a RDS gadget. I'm sorry if you have seen already this kind of information in the previous video, but I prefer to repeat it to the one who are interested on it. And I will 1216, don't remember the, no, 10. Okay, there is a root. No, so I SSH on the device. Come on. Okay. And now the default password is Acme system, like this. And so now we are connected to the board, and we'll go to the web page. And they said to go. A simple module called Acme Pins is available on GitHub to manage the GPO lines using the sysfs method. What is the sysfs method? So let's try to follow sysfs code for a moment, and then I will try. So I will do the bash way of read the pin. And right now I said I'm using PA24, and here they say H1 to export gpio. Okay, so I think this will enable HO, and this is read line status, so read in POA1. No, don't think so. Which one? POA1. POA1. What is POA1? I don't get it. There's only PO. One expert. I don't get it. Why there is only one PA? That's one chipset with the gpio lines organized by 32-bit port called PA, PBS, etc. Before to read to export, for example, now to set as the read the port PA1. Port pinout not. Okay, let's try. I don't understand how to export the right pin. Maybe I have to create one that doesn't exist. And then I start off line PA1. And if I want to PA27, where is PA1? I don't see PA1 here. So if I say POA24, what will happen? And does it make sense? Echo 1. It's an in, so slash direction, maybe yes. Okay, not such far a director as I suppose it to. For pinout. Okay, that makes more sense. Yeah, exactly. Pinout is correct. Currently it is. So the okay, let's try directly with this. Let's go again here. It okay. Thank God I got it. Oh, sorry. I have to connect the actually it's not connected to the internet, and I need to share this device to connect it to the internet, and I don't want to right now to do it. So let's see, I connected the I actually connected the Ethernet device. Let's try again. Now it works, and I cloned the project. Now I will do and echo in. No, what I'm doing. Python setup install. Let's see. Okay, they said it works. It's okay. Blinking LED, boot button reading polling mode. Okay, let's start with this. Is one. It's easier. Okay, I'm good. Come on. At least there is a nano. Nano. Okay. Acme pins, import gpio from time to import sleep. Foxboard, not interested. It's interesting. I can use the onboard gpio. I didn't know. And it's connected to PC 17. And then it says while true, wait 1 second. Why? Who cares of this counter? F button, digital reason 0, press it. What? So it stay here until the button is pressed, and then it will stay here until the button is released, and then I think I can say released. And for now it's okay like this, but the pinout, let's try PA24 and see what it happened. PA24. X Python test and stay. Oh wow, it works. Okay, now I'm actually trying to show you, and it works. I'm pressing and releasing. Press it. Now we'll released. Okay. And now this is the script. Come on, I won't give him. Vim because I prefer Vim to Nano. Nano, it's okay if you don't know Vim. I think Vim it's, but the truth is I know Vim better than Nano, so I prefer to use Nano. Prefer to use Vim. Of course, it doesn't make sense on this device to have two editors. It's better to have just one, it's enough. There are some error. Okay, it's first time I connected GPIO, control GPIO from this device. I already did with Raspberry Pi, another device. And I'm pretty satisfied of the result. It works the first time. I really didn't understand how this works. This SysFS method works, because I don't know where I can explain where is the how to create this device, this GPL line. But it's okay. Oh, come on, what are this doing? Okay, so now let's see how to call Python, call shutdown, maybe exec command, execute commands. Okay, over calling start command. This site, I like this site. Okay, perfect. Import os.system, and then here I will do shutdown -h now, or alt, should works. But what I want to do more is to count time between the pressed and the released. So before doing this, from import os and here, so this is a busy loop doing nothing apart from waiting, and it's stupid because it's better if I prefer tab instead of spaces. Okay, here I think I will wait 1 second at least. Maybe if I do leap 0.2, it will wait 200 milliseconds, and it's good enough. Just to not have a busy loop for just read the button press. And then here, so when it's pressed, I will say last time pressed here. I will search the callback to the command, and then here I will say if last time pressed I prefer to use parentheses. If current time millis minus last time pressed is bigger than 5 seconds, I think it's millisecond, then os point system alt. shutdown minus h now. Okay, so let's see how to grab Python, and let's close some tabs. Python, Python get current milliseconds. The epoch time milliseconds. What? I don't like so much to go to Stack Overflow, but it's okay. What I need is where okay, time. Microseconds. Really? How many answers? For me, it's enough to have seconds, because I want to know how many, at least if it's past 5 seconds. So time Python. Let's see what is that. The library time return time in seconds since the epoch as floating point number. So Python time. Import time. Yes. So if I said int time 1, 2, 3, it's enough. It's enough for my scope. It's okay. So I will do int time, and here I will do from time import from time import time, right? Wait. And now I will say okay. Whoa. Int time. It's bigger than, of course. Instead, else I will print released. Let's see. Whoa, error. Function or method object not true. Okay. You're right. So okay, if I'm pressing the actually the script is running as root, so the command will of course run. But if I will use another user, For example, I create a user, this maybe will not work. So it depends if the user that run the script have the right to shut down the board. So right now, let's see if I can just pressing the button, shut down the board or not. Okay, now I released. Nothing happens. The board seems closed. In fact, I don't have any response, but maybe I can at least print something on the screen when it's shut down. As you can see, there is pressed, but there's no released. And if I go right now to the network settings, I think I will not see anything, as you can see. So now I will connect again the board, and I will change the script a little bit. So another things important is this is a brutal shutdown. All the process will be closed, and if I have something running, the system should be at least right now I will close the board. But if I have something that is running, another script that is running, I have to take care of that script, so or another program. So I will have to create an init script for the shutdown process of the board, and before the shutdown of the board of the script itself. So now I will connect again. And so or maybe another good idea is to, this is a general script, it will work everywhere, anytime, with any process, with any Arietta board. But if I have to implement another script that run while the board is alive, I have to find a way to correctly shut down the process before the board shut down itself. And it's not really a problem. There is many ways to do it. So this will be called to test.p. I will call alt button dot p with py, and then alt button py, and here I will print at least print and shutting down. Bye. Okay, and now let's try again. And then another thing I've had to do is to make this script always available, and that it should run when the device is up as soon as possible. And let's try now. I'm pressing, and 1, 2, 3, 4, 5, shutting down. Bye. Okay, and the board is already disconnected. So I have to, the next time I have also to add this script to the I need to add the script in order to be run anytime the board goes up. It should run in the init this script, so you can monitor the button. If the button is pressed for more than 5 seconds, it should shut down the board. Okay, for now, for today is a good video. I'm pretty happy of the result. If you have any question, an idea, just write me in the comments. And if you have any idea on how to do other stuff, just ask me. If not, I will go on with my project on a USB, on a way to make the transfer of files from this terrible device safer for our computers. See you next time. Bye.